Okay, then in this video, we are going to find the value of torque on an electric dipole in a uniform electric field. That what is the value of torque on a dipole in a uniform electric field? If an electric dipole is placed in a uniform electric field, then what is the value of torque which it experiences? So suppose that this is the uniform electric field. This is the uniform electric field in which any dipole has been placed. Suppose this is the dipole, this is minus q charge and this is plus q charge. It has been placed. Okay, so then we have to find that what is the torque which will be applied on this dipole. As we know that this is mid center and this is called L or A, and this is also called L or A. Means this total distance, this total separation between both charges is 2L. Okay, this is L, this is L, means total it is 2L. As we know that if any charge is placed in a uniform electric field, then it experiences a force, and that force is equal to QE. Suppose this is the uniform electric field, this is the electric field, and any charge has been placed, suppose plus q charge is placed in this, then what happens? It experiences a force. And what is the value of that force? As we know that electric field is equal to force by charge, we have find that. So what will be force? Force would be equal to QE. Means if any charge is placed in a uniform electric field, then it experiences a force, and that force is equal to Q times of E, where Q is the charge, magnitude of charge, and E is the electric field. And what is the direction of that force? So if it is plus Q, then in the case of plus Q, the direction of force is in the direction of electric field. And if it is minus Q, then it is opposite to electric field. Why so? Why the direction of force in plus Q charge condition is along the field, and why in the case of minus Q charge it is opposite to the field? Due to matter of fact, we know that electric field originates from plus Q and terminates at minus Q. Means if an electric field lines are like this, it means that somewhere it is plus Q charge here, which is generating the electric field, and it is going toward negative charge. So if we place any plus Q charge in this electric field, what will happen? It will experience a force of repulsion, and due to this force of repulsion, it will move away from the plus Q charge. And if it is minus Q charge, then what will happen? It will experience a force of attraction, and it will move toward the plus Q charge. Okay, so if it is plus Q charge, then the direction of force in the uniform electric field on a charge is along the field, and if it is minus Q, then the direction of force is opposite to the electric field, and that force is equal to what? It's equal to QE. Okay, so this is plus Q charge and electric field is E. Then it will experience a force in this direction, and this force will be equal to Q times of E. Similarly, this is minus Q charge, so it will also experience a force, and that force will be equal to QE. But the direction is different. As you can see here, that this direction is along the electric field, and this direction is opposite to the electric field. Okay, so what will happen? What will this force will do? As we know that both the forces are equal and opposite to each other, because both charges are equal in magnitude in the case of dipole, and if both charges are equal in magnitude, it means that this force will be equal, and if this force will be equal, then this force will cancel to each other. Okay, so net force equal to what? Net force is equal to 0. F net is equal to 0. Means there is no force. Wait for some time. F net is equal to 0, means there is not any type of force on this dipole which will cause its translational motion. But the direction of force, the line of action of force is not same. The line of action of force is not same. As you can see here, the line of action of this force is this, and line of action of this force is this. So line of action is not same, and if line of action is not same, then maybe it will not cause any type of translational motion, but it will must cause a rotational motion. Suppose that this is the dipole, and if I am exerting a force along this and along this tip, okay, if both forces are equal, suppose I am exerting a force on this and exerting a force on this, and if both forces are equal, then what will happen? It will not move because both forces are equal in opposite direction, so it will cancel to each other, but it will cause the rotation. It is called a revolution of this marker, of this body. Okay, so similarly this force is exerting on this force is like this, so it will rotate, it will just rotate the dipole, and that force which rotates anything is called what? Is called torque. So we have to find that what is the value of torque which it will experience. What is the value of torque which it will experience? Okay, so as we know that what is the value of torque, what is the formula of torque? Formula of torque is force multiplied by the perpendicular distance between line of action. The perpendicular distance between line of action. Okay, so what is force? You can take any one force, like this force is okay, minus QE, you can write, and but I am only talking about magnitude, not about direction and sign. So we can take either a force. So force is equal to what? Q times E. And what is the perpendicular distance to line of action? As we know that this is line of action for first force and this is line of action for second force, then what will be perpendicular distance between both? This will be perpendicular distance. Okay, this will be the perpendicular distance. And suppose this dipole is making an angle theta with the electric field. Okay, so what will be value of this perpendicular distance? As you know that this is 2L, then this will be 2L cos theta, and this will be 2L sin theta. We know it from very basic of the physics that this is what? 2L cos theta, this is 2L sin theta. Suppose that if this is A, this is B, this is C, so we can say that in triangle ABC we can say that sin theta is equal to what? Sin theta is equal to BC by AC. So BC will be equal to what? Sin theta multiplied to AC. So sin theta, and what is AC? AC is equal to 2L. So this is 2L sin theta, this is 2L sin theta, and this is what? 2L cos theta. So QE into 2L sin theta, and we can write it as QE, or we can write it as Q into 2L into E sin theta. And we know that what is Q into 2L? This is dipole moment. Q into 2L is what? Dipole moment. We know this. Dipole moment is equal to Q into 2L. So this is P E sin theta. So we have found torque is equal to P E sin theta. Okay, as we know that torque is a vector quantity, P is vector quantity, and E is also vector quantity, and this is sin theta, means this is a type of cross product of vector, and if this is cross product, then we can write it as torque is equal to P, vector torque is equal to vector P cross vector E, vector P cross vector E. So this is in the scalar form, and this is in the vector form. Okay, means torque is equal to what? P cross A or PE sin theta. Now we can find that in which condition the value of torque will be maximum, and in which condition of dipole the value of torque will be minimum, and we are going to find it. Have you understood this properly? Okay, listen again. This is the dipole which has been placed in a uniform electric field. So this is plus Q experiencing a force in this direction along the field. Force is equal to QE. This is minus Q experiencing a force opposite to the field, this is equal to also QE. Since both the forces are equal and opposite, so net force is equal to 0. But since line of action is not same, if line of action will also be same, then there will be no any type of torque evolve. But since their line of action is not same, so it will experience a torque, and that torque will be equal to force into perpendicular distance between line of action. Force is equal to what? QE. Perpendicular distance is what? This is perpendicular distance, which is equal to 12 sine theta. This is theta, so this is equal to 12 cos theta. This is equal to 12 sine theta. So Q into 2 into E sine theta. Q into 2 is equal to P. Okay, this is E sine theta. So torque is equal to P E sine theta. Torque vector is equal to P cross E. And now we are going to find that in which condition torque will be maximum and which condition torque will be minimum. Okay. So if you want, you can take a screenshot of this, or you can write it by pausing the video. Okay. Then we can consider case 1. In this condition, torque is maximum. So when torque is maximum, we know that torque is equal to what? Pe sine theta. Okay. So sine theta, the variable here is sine theta, and we know that sine theta. And what is theta? Have you studied it in the vector? What is theta? Angle between P and E. Angle between, what is P? Dipole moment, which is from minus Q to plus Q, and E is electric field. So torque is equal to Pe sine theta. So if you will talk about that, what will be its maximum value? So it will depend obviously on sine theta, and sine theta, the maximum value of sine theta is +1. We know that maximum value ranges from +1 to -1. So maximum value of sine theta, maximum value of sine theta is equal to +1, and it occurs at theta is equal to 90 degree. Means if this is electric field and this is the dipole, this is the dipole, okay, and if it will make, this is the dipole, and if it will make 90 degree angle with the electric field, as you can say that this is the dipole moment, and sorry, minus Q to plus Q, it is minus Q to plus Q, and it is making an angle of 90 degree with electric field. So in this condition the torque will be maximum. And what will be the effect of torque? Torque will just try to rearrange itself in such a direction that torque should be 0. And when this torque will be 0, so just take case 2, that when torque is equal to 0. So torque is equal to 0 when sine theta is equal to 0, and when theta is equal to 0, when theta is equal to 0 degree. Theta is equal to 0 degree means if this is electric field, if this is what? Electric field, then the dipole should be placed in such a order that the dipole moment minus Q to plus Q, this should make an angle 0 degree. Now you can say here that P is making angle 0 degree with the E, and in this situation we can see that since theta is equal to 0 degree, so sin theta is equal to 0, torque is equal to 0, means there is no torque in this case. As you can say, why? Because force F is equal to QE, F is equal to QE, and now in this condition there is no different line of action. Both forces have same line of action, and that's why force is equal to 0. Both forces have same line of action, and that's why torque is not present here. But in this condition also you can say that torque is, you can also see here that line of action is not same. Line of action is like this, line of action is this, not same. But in this case line of action is same, that's why it has torque 0. So this is the value. So you have to keep in mind that torque is equal to Pe sine theta in the scalar form. Is visible? Yes. And torque in the vector form is equal to P cross E. Okay. And this is in case first, in this theta is 90 degree and theta is 90 degree, then there will be maximum torque in this. And what will torque will cause? Torque will just try to arrange it in such an order that theta should be 0 degree, means there should be not be torque. The torque will just minimize the itself. So in this situation theta is equal to 0 degree and That's why torque is also equal to 0 degree. Okay, then write it. We'll now talk about another topic in the next video. Till then, keep studying. Okay, thanks.